Convolutional neural networks also has many hyperparameters. In this video, I will explain some of them. First of all, convolutional neural network have to control the map size. At each layer, we have to decide the shape of input map and output map. Okay, so when you have input map like this, and the output map shape, this will be decided by the filter shape, right? For this filter, basically the depth, the filter depth will be equal to the number of channels of your input map. So this Cin will be the equal with this value. But the shape, the width and height of the filter will decide the output shape, output map shape. So for instance, if your input map is 12 by 12 with Cin number of channel, and if you use 3 by 3 times Cin shape of filter, then what is the output map shape? The output map shape will be 10 by 10. Why? When you have 12 number of pixel here, 12 number of pixel here, when you locate the 3 by 3 filter here, how many pixels remained here is 9. So you can move this filter 9 times. After that, your filter reaches to the corner. Okay, so this is the first value, and you can move 9 times. So you can find 10 value, 10 local behavior. Vertically, same. You can move 9 times more, so you have 10 different local information you can obtain for one vertical line. Okay, so generally, when you have W in and H in, width and height, and from this you can directly calculate the output shape using W in minus K plus 1, W H in minus K plus 1. So this will be the output map shape. And the number of channels of your output map can be controlled by the number of filters. Number of filters will decide the depth, the number of channels of your output map. Okay. But actually, we can control the height and width of your output map by padding and stride. So the input image has boundary, right? And the boundary effect is usually also some problem, some issue. It can also make some issue. How to deal with the boundary? Because boundary definitely different with the center position. So how to deal with the boundary is also very, one of the issues for image computer vision research. So when you apply the convolution neural network, we can use some zero padding. So zero padding means to increase the dimension of your input and then fill the outside area with zero value. So this was H in, this was W in. But you can increase the input dimension by zero padding. So when the padding size is 1, the real input image shape for the neural network will be W in plus 2 here and H in plus 2 here. When the padding size is 2, then this will be W in plus 1 and H in plus 4. So your output shape will become W in plus 2 times padding size minus filter size plus 1. This will be W out and H out as well. H in plus 2 times padding minus K plus 1. Okay. So for 3x3 filter, when P is equal to 1, you can keep the same image shape. Stride, you can control the map size using stride. Stride means when you do filtering, you don't need to move the filter position one by one. Maybe sometimes it might be better to move your filter by 2. First sample here. First observe the local behavior here and then move the position by 2 pixels and then observe this. So the jump size is called stride, and the stride value can control the filter shape and can control the output shape. And essentially the H out will be H in plus 2 times padding minus corner size, right? So this is the remaining pixel when you put your filter at the top left corner. So when you have stride size S, your remaining time you can move will be H in plus 2P minus K over S. And because you already observed the first top left corner, this is this one. If this is not the integer value, you just remove the point. You just take the floor operation to make the integer. Okay, so using stride and padding, you can control the number of neurons essentially because you can control the shape. Right. And another approach to control the map size or map shape is pooling. Pooling operation is very simple. There are two common pooling methods. One is max pooling and the other one is average pooling. So when you take the filtering, essentially here the filter does not have any parameter value. Just go there and see if the filter size is 3, then go there and see the value of 3 by 3 area, and then take the max value. That is max pooling. Average pooling is go there and see the 3 by 3 area and take the average. That is average pooling. Okay, so the pooling is one kind of a convolutional process without any parameter with some simple function. Okay, so because this is also some kind of filtering process, you can introduce strides and padding for the max pooling and averaging process. So without any additional parameter, you can control the shape of the output. So normally in the convolutional neural net architecture, we use max pooling to reduce the width and height of your output map. So yeah, it is very difficult to say why max pooling and average pooling can improve the performance, why reducing the map size can good for the image classification task and so on. It is very hard to difficult to say the answer. But empirically, it is shown that with the max pooling, average pooling, you can get better result. Okay. So essentially for deep learning, sometimes you have to just believe the result. There is no clear theoretical explanation.